This is Physical Chemistry, Part 3, Quantum Chemistry, Chapter 12, From Classical to Quantum Mechanics, Section 12.1, Why Study Quantum Mechanics? So first, let's compare thermodynamics and quantum mechanics. In thermodynamics, we study the behavior of matter and transformation of energy on a macroscopic scale. In quantum mechanics, we also study the matter and energy, but on a microscopic scale. So what's the difference between macro and micro? Well, macroscopic scale, we look at a human scale. The units are kilogram for mass, meter for length, kilojoule or joule for energy. Microscopic, we're looking at molecules or atoms. We're looking at 10 to the power of negative 23 kilograms for atoms or molecules. We use angstroms or nanometers for length. What about energy? Very small, 10 to the power of negative 20 joule. And sometimes we use atomic units in quantum mechanics. In thermodynamics, we study most of atoms. In quantum mechanics, we study a few atoms. In thermodynamics, we look at the average property of moles of particles. In quantum mechanics, we study the properties of individual atoms or molecules. But why do we use quantum mechanics to describe the microscopic particles instead of classical mechanics? Well, classical mechanics cannot explain the wave-particle duality of matter. Classical mechanics cannot explain the electronic structures of atoms and molecules. Electrons are simply not classical particles. Finally, classical mechanics cannot explain the quantization of energy. In classical mechanics, energy is always continuous. In quantum mechanics, energy is quantized.